stuff. So here you're gonna have the thiol, the SH is gonna be over here, and you're gonna have an alkyl halide over here, right? To make that.
That's you.
And then methyl neopentyl, you'll want the substitution to happen on the methyl and the alcohol to be on the neopentyl. Right, your alcohol should always be on the more substituted one.
Sorry, that's not
All right, this one you just need to predict the product. Everybody can do that, right?
tonight.
Stick an O ethyl here instead of the bromine.
It asks for the major, so
It's primary.
okay. Is that possible? We have to draw two compound in one answer.
There will always be a major and a minor.
Okay.
So you just substituted the bromine with an O ethyl. That was your nucleophile right there. Huh? What's the matter? It's substitution. This is the nucleophile, and that's the leaving group.
How is a methyl pentyl ether looks like?
You're gonna have to give me something to work with here.
So,
Oh.
I know it's substitution because it's primary. The only way you'll get elimination as the major product on a primary carbon is if you use a bulky base. Okay? This is a base and a nucleophile. Since it's gonna do substitution, that means it's the nucleophile, so this oxygen takes the place of this bromine and it keeps the carbons attached.
oh, maybe that's why I just didn't understand that ethyl on there too.
Oh yeah, ET ethyl, 2 carbons.
Oh, okay, maybe that's it.
Then the minor product is going to be elimination. So whatever this was, 1, 2, 3, 4, 5 carbons with a double bond. The major product would be produced by an SN2, minor product by E2, because it is primary and strong, or non-hindered, okay. So that's the sort of stuff you're looking for. This one is really about, do you understand the differences between the mechanisms?
Phenol is connect to the link.
Spell what you're saying, because it,
Phenol, PHENYL.
okay, phenyl is a double, or a benzene ring directly connected to something.
So benzo is one more carbon.
Yes, one more carbon in between.
So phenol plus a CH2.
Yeah. Alright, so then the difference, this time because it's terbutoxide, that's a bulky base. Alright, so this one's gonna favor elimination and just do a little substitution. So your major product would be the double bond, your minor product would be substitution. And then it favors E2 first and then SN2 second. And it is primary and hindered strong base. Okay, so it's all stuff like that the whole way through. The next one, you have a strong base and the tertiary carbon, so what's gonna happen?
Strong base and tertiary carbon. E2. E2.
Strong base with the tertiary carbon is gonna do E2. And then the second, like the next possibility would be, actually it doesn't even ask for that. Terbutoxide is also gonna do E2. It would do E2 no matter what it was.
So when you do elimination, you put the double bond instead of like switching them out?
Yeah, that's what elimination means, is it loses,
You just don't add anything to the end of that double bond, it just stays with carbon?
right, it's just carbon. This one's secondary, not a base. So what would that do?
Substitution.
SN2. So you would draw your iodine pointing down instead of where 5 degrees, so low temperature, what are you gonna get?
SN.
It's tertiary,
What?
SN1.
Oh,
And then minor product would be elimination.
What is considered high? 50 is high or?
There's no, it's not gonna be, it's different every reaction.
So why you say 25 is low?
It's just room temperature.
Okay.
You haven't heated it at all, it's at room temperature. But there is no definite, this number is high temperature. There are some reactions that you have to cool with liquid nitrogen to keep it from doing what you don't want it to do. And their room temperature would be really hot. Anyway, all of these questions are really about understanding the mechanisms. So what I would do before you guys go back in and do more of this is really sit down and read this chapter and try to really understand. You must have got it.
One question.
Okay.
Methyl bromide with water. What will it become? Methanol. But I type in methanol, it says, what? Yeah, that's wrong.
It might be no reaction, then it probably would need heat or acid or something to make that work.
I'm confused, this may sound stupid, but on the first part of the equation, why are you doing SN2 and elimination? I thought it had to be one or the other.
No, that's, the main point, like the underlying theme of this entire chapter, is there is never a time when you will get just one of these. You will always have one that you get more of and one that you get less of, but you will always get a mixture, especially if it's secondary. If it's primary, you can pretty well get mostly substitution, with just a little elimination.
But it's still
But if it's secondary, you're gonna get E1, or not E1, but you'll get SN1, SN2, and E2.
We get all of them.
And you can control which one you get more of by adjusting the condition. And that's really the underlying theme of the whole chapter.
Okay. I think I missed that point. But I did one.
It's just being a little bit hectic.
Methyl bromide with water. No, I was trying to write the red.
Well, it's gotta be methanol.
Methanol, yeah, but
I
the
heard